So first of all, I will perform all basic practicals of STP, and then I will go for like STP protection, right? Like VPD guard, root guard, loop guard, everything, right? So let's start from the STP basic practicals. I want to show you that what is the uses of uplink fast, or like if you are comfortable with that, with those practicals, then I can move directly for STP protection. Should we go for uplink fast and backbone fast and all these things? Okay, then let me do one thing. This is 127. Yeah, that's fine. Switch 1. Sorry. This is switch 2. Switch 3. This is switch 4. Alright, we are on switch 1. You know very well that switch 1 would be connected with switch 2 as well as switch 3, and of course switch 4. And also you understand the physical topology of these switches as well, right? So first of all, let me note down the MAC addresses of each switch now. Show version. Because by default all switches will be having same priority, so of course final decision will be based on MAC addresses. Like show spanning. that trunking will come up in between switch 1 and switch 2, right? Show spanning tree. Is this switch have been elected as a root bridge? No. And one more thing, by default here on all Cisco switches you will see that PVST will be running, PVST plus actually. What is the difference in between STP and PVST actually? Like in STP, first of all they launched CST, common spanning tree. In case of common spanning tree, there will be only a single instance of STP for all VLANs, right? Like for an example, if you are having this kind of diagram, something like that, right? If this switch 1 is root bridge, it means it will be root bridge for all VLANs now. Doesn't matter that how many VLANs are there. If you are running, if this switch port is in blocking state, it means that it will be in blocking state for all VLANs. In case of, so there was no load balancing actually, right? So for that purpose Cisco launched this PVST, and PVST was not having like it was not supported by .1 queue, it was supported with ISL only. So finally they launched, which can be configured with .1 queue as well, with .1 queue encapsulation trunk encapsulation protocol, right? So in this way now, you can understand that what is the necessity of having this PVST plus on all switches, right? Because if you are having multiple VLANs, so for some VLANs you will try to configure one switch as a root bridge, for some other VLANs you will always try to configure any other switch as a root bridge, right, for the purpose of load balancing. In same manner, like for an example, if you are having a very small diagram of two switches only, let's say this is switch 1 and this is switch 2, and if you are having two links available here in between switch 1 and switch 2, so let's say this is DP, this is DP, this is RP, and this is in blocking state, and it means that it will be in blocking state for all VLANs now. But what can you achieve here with using PVST plus, that for some VLANs you can configure it as RP, for some other VLANs you can configure this port as a RP, so that it will also start to perform load balancing along with redundancy. So by default, like for an example, if you are running CST, then you will never get any type of load balancing, but if you are running PVST, then you can also achieve load balancing. But remember that by default in PVST plus also you will never get load balancing, right? Because by default for all VLANs you will find that only one switch will be working as a root bridge, and by default only one port will be root port for all VLANs. So remember that by default PVST plus also do not perform any type of load balancing. But if you want to perform load balancing with using PVST plus, then of course you will require to do some modification in your existing STP topology, right? So we can do that actually to achieve load balancing. So that is the advantage of having this PVST over CST. I hope that you have, you know about all these things already. So now what can we say here, like as you can see here, which switch is having best MAC address? Switch 3 or switch 4? Of course switch 3 is having the best MAC address, right? So it means if you move on switch 3, now it must be configured as a root bridge. Let's check it out. For all VLANs, as you can see that here, if it is having multiple VLANs, like it is having VLAN 22, so for VLAN 22 also it is working as a root bridge. Now because default topology is something like this here, like you are having 4 switches. This is your default topology, right? This is 21, 22. switch to switch 4. This is right. So because this switch 3 has been elected as a root bridge, it means this all these interfaces will be DP. And now on switch 1, 19 must be configured as a RP, 20 must be in blocking. On switch 2, 23 must be RP and 24 must be in blocking state. And switch 4, 21 must be RP and 22 must be in blocking state. Now, in between switch 1 and switch 4, because the cost to reach root bridge will be same for DP election, right? Cost will be same. So, I mean, from switch 1 it can reach switch 3, from switch 4 also it can reach switch 3 in this way. Like BPDUs can come from there to here, and BPDUs can also go from here to there. So in both direction cost is going to be same, right? So here now they will compare their designated bridge ID. So either switch 1 is having lower bridge ID or switch 4. So to check that, of course switch 4. Switch 1 is not having lower bridge ID, is not it? So it means that according to the MAC address, of course switch 4, I mean this end must be configured as a DP and both of them must be in blocking state. In same manner, you will also elect DP in between switch 1 and switch 2 as well, right? So if BPDU is going from switch 3 to switch 2 and going towards switch 1, and if BPDU is going from switch 3 to switch 1 and coming to switch 2, the cost is again going to be same, is not it? So because cost will be same, so again designated bridge ID will take place to elect your DP. So to elect your DP, then definitely we can do one thing, we can compare their MAC addresses. So I mean in between switch 1 and switch 2, which switch is having lower MAC address? Of course switch 1, is not it? So switch 1's, I mean this end must be configured as a DP and this end must be in blocking state. In same manner, if you compare the MAC addresses of switch 2 and switch 4, then of course switch 4 is having lower MAC address, so it will be DP, and here, so this should be your result actually, is not it, Umar? So if you move on R1, now you can see that 19 must be RP, 19 must be RP, 20 must be in blocking state, 23 and 24 both of them must be in blocking state, and 21 and 22 must be DP. So let's start it from switch 1 itself. What can we do? So spanning tree, VLAN 1, check it out. 19 is RP, 20 is block, 21, 22 are DP, and 23 and 24 are in blocking state, same as this diagram. Fine. Then after you can also move on stage 2, except 23 all others are in blocking state on stage 2, is not it? So if you move on stage 2, say show spanning tree, you will see except 23 all are in blocking state. See, only 23 is working as a RP. Whereas on switch 4, 21 will be RP, 22 will be block, except it 19, 20, 23, 24 will be DP. So you can move on switch 4 now, and you can say show spanning tree. Check it out. 21 is root, 22 is block, all others are DP. And definitely on switch 3, all of them will be DP. I hope that now you are okay with it, right? So in this way it can perform election. Then let's do one thing, let's have topology of two switches only now, switch 1 and switch 2. Here is gonna to be like 21 and this is gonna to be 22, right? Because switch 1 and switch 2 are interconnected with using 21 and 22. So I'm gonna to disable, I'm gonna to shut down all other interfaces here now, so that I can prove all these things whichever I taught you in previous class, right? So on switch 1 interface, range fast Ethernet 1/0/19 to 20, then fast Ethernet 1/0/23 to 24, and shut down them. Same command will be configured now. See, its MAC addressing time will be configured equal to 15 seconds because your trunk port have gone down, so it will generate TCN, and if any switch generates TCN or receives TCN, then definitely it will always configure its MAC addressing time equal to forward delay timer, which is by default 15 seconds. Show spanning tree, 15 seconds. Fine. So in this way you can see that now it is, only switch 1 and switch 2 are interconnected, right? And switch 1 have been elected as a root bridge. You can see show spanning tree. Check it out. Even let me do one thing, show ADP status. No VLAN is like 1, 2.
1 to 4.
Only VLAN 1 is there, right? Show VLAN brief. No VLAN, right? Only VLAN 1 is there. So right now you can see that switch 1 is working as a root bridge. If I want to configure the switch 2 as a root bridge, then you can say spanning tree VLAN 1 to 4094 for all VLANs, right? Either root, primary, or say priority. And priority can be configured in the increment of 4096 only due to PVST, right?
Yeah.
Due to PVST. Otherwise, like if you are running CST, then there will not be any requirement something like this, like your priority must be configured in the increment of 4096, because there will be only one instance of STP. But this time, because your VLANs can be up to 4096, up to from 0 to 4095, right? That is why here you have to say that the decrement must be of 4096 whenever you will go for priority. If you don't follow this rule, then of course on a single switch for multiple VLANs, for multiple instances of STP, your bridge ID can be same. I'll discuss it later on with you, right?
Yeah.
This is really mandatory. If you are not following this rule, it means that for multiple instances of STP you can have common bridge ID.
Yeah, because it's a system extended ID, right? Which is the priority plus.
No, I will be discussing it with you. Fine. So this time switch 1 is working as a root bridge, as you can see here, shows spanning tree. And on switch 2, as you can see that 21 have been elected as a root port. You see, check it out, right? This is root port now. And if you configure multiple VLANs here, like VLAN 1 to 5, sorry, VLAN 1 to 10. So how many VLANs will be there now?
10 plus.
Show VLAN brief, check it out. 10 VLANs will be there, right? For each VLAN now it will be root bridge, right? As you can see, show spanning tree VLAN 1. It will say that I am root bridge. For VLAN 10 as well, it will say I am root bridge. For VLAN 9 as well, it will say I am root bridge. Show spanning tree VLAN 11. Is there any instance for VLAN 11 by default? No. So STP will never run an instance of STP for that VLAN which do not exist in its own database. Fine. So STP will always run instances of STP only for those VLANs which are available in its own database. And one more thing, if there is no trunk port, if there is trunk port available, and if all VLANs are allowed through that trunk port, then only STP will run instance for each available VLAN in its own database, right? If there is no trunk port, let's say that right now we are having 10 VLANs, right? Show VLAN brief. We are having 10 VLANs. Are we having any VLAN member in any VLAN? Of course we are having, but in VLAN 1 only. So if you do one thing, interface range fast Ethernet 1/0/21 to 22, and you say switch port mode access. So I've configured these two interfaces as an access port now, right? And you will see now, show spanning tree. Is STP running for any other VLAN now except VLAN 1? Is it running for any other VLAN? Now it is, the instance of STP is running only for VLAN 1. You know why? Because you configured 21 and 22 as an access port, and by default access VLAN is configured as VLAN 1. So right now VLAN 1 is having member here on this switch. That is why STP is running one instance of STP for VLAN 1 only, right? It is not running instance of STP for any other VLAN. You know why? Because there is no trunk port available now. Show interface is trunk, and also there is no port available in any other VLAN, right? So if STP thinks that for this VLAN we do not have any port member, for this VLAN we do not have any VLAN member, and also this VLAN is not allowed on your trunk port, it will never run an instance, it will never run instance of STP for that specific VLAN, right? So this time you can see interface range fast Ethernet 1/0/21 to 22, and again I will say switch port mode dynamic desirable, and again you will see that it will become trunk port, and again this switch 1 will start to run instance of STP for each VLAN now, because all VLANs are allowed through this trunk port. So now show spanning tree in VLAN 1. Of course, you will get result of VLAN 1, and of course you must get the result of VLAN 2 as well, and VLAN 3 as well, and VLAN 4 as well, for all VLANs, right?
So in this configure a trunk and we do not allow a VLAN, right?
Then again there will be problem. There will be problem again.
But will it run an instance of spanning tree?
Like for example, do show interfaces trunk interface range fast Ethernet 1/0/21 to 22 switch port trunk allowed VLAN remove 6. Now VLAN 6 is not allowed for this trunk port now, right? So interface is trunk. Is it allowed now? And are we having any port member, any interface inside this VLAN 6? So now show spanning tree VLAN 6. But it will be having instance of VLAN 5. Fine. Spanning tree, switch port trunk allowed VLAN all. Show spanning tree VLAN 6. It's not it. So in this way STP works. Second thing, let's move again back on switch 2. Show spanning tree. You know very well that for all VLANs, its 21 is configured as a RP, as you can see here. If I want to get some load balancing, like I want that for VLAN 1 to 5, of course 21 should remain as RP, but for VLAN 6 to 10, its RP should be configured 22. 22 should be configured as a RP for VLAN 6 to 10. So interface range, interface fast Ethernet 1/0/22.
Spanning tree VLAN cost.
Yeah, the very first thing that you can modify the selection, you can manipulate the selection by modifying its cost. And remember that if you are going to manipulate your RP election based on cost must be changed at the end of receiving.
Yes.
At non-DP end. If you change the cost of DP, it will never affect your RP election. Like I'm going to say that if you are having this kind of diagram of two switches, if you are changing, let's say our switch 1 is working as a root bridge. If you are changing the cost of interfaces at the end of switch 1, it will never affect your RP election. If you change cost at the end of DP here, at the end of root bridge, it will never affect your
when it changes the BPDU, it changes the
zero cost BPDUs. So it will never add the cost of outgoing interfaces. Only and only receiving interface will add its own cost inside the total cost in received BPD messages. Matthew, are you okay with it? So remember that whenever you will try to manipulate your RP election based on cost, then you have to change it at the end of non-DP only. It means here in this case, because switch 2 is the non-DP end, right? So you will change your cost at the end of switch 2 only. So let's move on switch 2 now first of all, and on switch 2 I'll be doing that now. Let's say that I wanted to configure this 0/22 as a RP for VLAN 6 to 10. So now we are having two options. Either we can reduce the cost of 22 for VLAN 6 to 10 only, or we can also add some more cost on 21 for VLAN 6 to 10. Finally, we have to define the cost of 22 for VLAN 6 to 10 lower than 21. So right now what can I say here? I can say spanning tree cost, right, lower than 21, and by default their cost is 19. Here I can configure it as 18. So if I configure this cost 18 in this manner, so it will change this cost for all VLANs, right? It means now this port 22 will become RP for all VLANs now, right? But I wanted to configure this 22 as a RP for only VLAN 6 to 10, right? So what will I say now? Spanning tree VLAN 6 to 10, and then I can say cost like what, 18. So this time you will see that this 22 will become RP root port, but only for VLAN 6 to 10. Let me show you now. For VLAN 121 is still working as a root port. For VLAN 2 also, 3 also, 4 also, 5 also, but for 6, check it out. Matthew. So in this way you can perform manipulation by modifying the cost of the interfaces. Is there any problem now?
We can also change the priority at the sender end.
Of course we can. I'll do that. Don't worry about that. I'll do that. So this time you can see all these things fine. And then after I would also like to tell you that like I've done it in this way, you can manipulate your RP election by using cost. So now interface range fast Ethernet 0 by 21 by 0 by 22, and then you can remove that command from here, like noise spanning. You can configure noise spanning 3 billion 6 to time cost 18 fine. So now you can see show spanning 3 billion 1 2 3 4 5 6 7 for all variants once again, right? Now what I want that 22 should be configured as a RP for variant 1 to 5, but you are not allowed to do modification at the end of sys 2 now. Means that you cannot modify your cost now, right? You are not allowed to use cost to manipulate this path selection now. So in that case you can also modify your designated port ID, because you cannot modify here. You cannot manipulate this RP election based on designated bridge ID. You have to skip designated bridge ID after cost, because after cost it is designated bridge ID. But in terms of sys 2 here, designated bridge ID on both interfaces will always remain same. On switch 1 is not it. Whatever you will configure on switch 1 like bridge ID,
Yeah.
it will become
For
common
both the ports.
for switch 2 on both interfaces, on both links, right? So finally here you cannot manipulate your RP election based on designated bridge ID, but definitely you can manipulate this RP election based on designated port ID. Fine. So what I want that this 22 must be configured as RP for VLAN 1 to 5. So now what can we do? We can move again back on switch 1 and we can say show spanning tree VLAN. Let's say show spanning tree VLAN 5 or VLAN 6, because VLAN 5 actually, because this time I wanted to make changes for VLAN 1 to 5. So for VLAN 1 you can see that for 21 and 22 their priority is what? 128. However, interface ID 23 is lower than 24, right? So what can we do? Either for VLAN 1 to 5 define higher port priority on 21 or define lower port priority on 22. Result will remain same. So you can see now fast Ethernet 1 by 0 by 20. What do you want? 22 or 21? So you can say spanning tree VLAN 1 to 5 port priority higher than 128. So next value will be, because port priority can be configured in the increment of 16 only. So after 128 it will be 144. There is a rule of configuring this port priority that it can be configured in the increment of 16 only. So next will be 144 on 21. So once you will configure it here, let's say show spanning tree VLAN 1. Check it out. Still it will remain as DP. It's not it, but now you can see that on 21 its port priority has been configured as 144. But for VLAN 6, of course, it will remain same. See, for both of them. Actual impact will be on switch 2. So spanning tree VLAN 1. Check it out. Its RP is now 22. But for VLAN 5 also its RP will be 22. But for VLAN 6, its RP will remain 21. Any problem in it? So you can manipulate your RP election based on cost as well as based on designated port ID. Let me show you one more command here. Show spanning tree VLAN 1 interface fast Ethernet 1 by 0 by 21, and then you can say detail. Now 21 is in blocking state. This is the port path cost. This is the cost of our interface, right? And port priority 128 is our own priority, right? This is port identifier. This is our own port identifier. Fine. And then designated root priority. This is the bridge ID. This is the priority of bridge ID, right? This is the system priority of bridge ID 32769. Because this is VLAN 1, right? For VLAN 1 its priority will always be 32769, because by default system ID extended feature is enabled. So remember that whatever you have configured system priority, bridge priority on your device, VLAN number will always be added into your bridge priority. Like if it is VLAN 1, it means 1 will be added in your bridge priority, which is by default 32768. So overall it will become 32769 for VLAN 1. And this is the MAC address of designated bridge. Designated bridge has private designated bridge. This, see, there are two things: designated root and designated bridge ID. Designated root ID means root bridge ID. Designated bridge ID from where we are getting the BPDU. Sometimes both of them will be common. Sometimes both of them will be different. If your designated bridge is the root bridge, in that case, these both things will be same.
Designated bridge means sender bridge.
Exactly. If sender bridge is not a root bridge, for an example, let's say behind switch 2 you are having another switch, switch 3. In case of switch 3, whenever you will check this, you will run this command on switch 3, you will find in designated bridge ID it will be bridge, it will be bridge ID of switch 2, but in root bridge ID it will be bridge ID of switch 1. So I hope that now you have understood the meaning by this designated bridge ID and root bridge ID. Fine. So then after you are also having designated port ID. This is the designated port ID and this is designated path cost. It means we are receiving zero cost BPDU.
Yep.
This will be that cost which is told by BPDU or which is coming inside the BPDU to reach root bridge, right? And then this is like messages by default and all these things, right? Point to point by default it have transmit 3 BPDUs at initial level because this is working as non DP, right? So it will keep on to receive BPDU messages. Then you can also see the output for 22 as well. 22 must be configured as a RP, as you can see. So I hope that now you have understood it, that how can we manipulate it, right? But still, let me show you that if your, let's say for an example, let me do one thing. Again, I will be having only one VLAN here. No VLAN 1 to 100. Do show history. Let me remove this command as well. Show spanning tree. It will again have default port ID, right? Show spanning tree. Again 21 will become RP. Is not it? 21 have again become root port. Okay. Then after I will show you that if your RP goes down, then it will take at least 30 seconds to move into forwarding state.
Before that, I just have a quick question on where we. This was regarding how to manipulate the root port
RP election.
for the
Sure.
But if we want to configure the root bridge election, if we want to configure the root bridge
manipulate, right? If you want to manipulate,
then there is either you can change the priority of the switch,
this priority,
or there is a command which is root
primary or secondary. Yeah, for sure.
Primary make it the priority as 24,000 something.
Yeah, I'll be discussing each and everything with you. Yeah, sure.
And
that's to you.
And secondary make it at 28,000 or something.
Yeah, if you are using default priority, right?
Yeah.
If you're on your switch you are having default priority like 32768, and if you say primary, then it will configure its bridge priority as 24576, and if you say secondary, then it will always configure its bridge priority as 28672, right? And also it will be depending on that which switch is having lowest priority.
Yeah.
If your switch is having lowest priority as 8192,
Yeah.
8192, and if you configure now primary keyword on any other switch, then it will configure its priority as 4096 automatically.
But will it change the secondary as well?
No.
It will keep. It will
4096 only. 4096. Now it cannot have.
Primary will make. If wherever we have configured primary, if there is any other switch which has a priority lower than 24,000, then it will make it to 4096.
Yeah.
But if we make any switch as secondary,
Not something like that.
so the secondary priority will not.
No. I'm not, it is not true that okay, if your base priority is 24576 already configured, right? And then you moved on any other switch, and again you said that this is primary, right? So it doesn't mean that it will always configure 4096. No, it will configure lower than 24576 actually. It's not always mandatory that it will always configure its priority as 4096.
Okay. So say for example, if there are 3 switches in the network, for switch 1 to 5 you have made this as a root bridge, for 5, 6 to 10 you have made this as a root bridge. And if there is through priority command. So switch one is having a priority. Switch one is having a root primary command, and switch two is having the root secondary command.
Yeah.
Now there is a switch 3 in the network which has the priority of say 8192.
Then it will become root breeze.
This will become root B, but I think wherever you have configured primary will automatically drop its priority to lesser than 8192, right?
But then when you configure primary keyword after configuring that switch priority as 8192. But if you have already configured your primary keyword and then after you are moving on any other switch and then after you are configuring its priority as 8192, then it will become root breeze automatically.
Oh.
But if already you have configured your breeze priority as 8192 on any one of these switches and then after you are running this primary keyword.
So it's basically
primary
first
command.
of all exchange the BPDU with all the switches. Okay, fine. But will it? I mean, will the secondary behavior will also be changed?
That's why we always say that all switches must be having default priority, so that secondary can also take place. Otherwise, if you are having, if you are not having default priority on all switches, then of course secondary, I don't think so that it will take place.
Okay.
Only primary keyword will take place. Let me show you now. So I hope that now you have gone through this RP election, right? You can easily manipulate it, that how to, this manipulation of RP. And also I have shown you that you can also run this command to check that what are the credentials of neighbor switch and what are the credentials of our switch, right? So this command will really help you. Then after, what can we do that I can move back again on switch 1, do show history, and interface range fast Ethernet 1 by 0 by 19 to 20 and fast Ethernet 1 by 0 by 23 to 24, and then say no shutdown. On switch 2 also interface range fast Ethernet 1 by 0 by 19 to 20 and fast Ethernet 1 by 0 by 23 to 24, say no shutdown. And all of them are having this default priority, right? So spanning. And once again you will see that switch 3 will become root breeze for all switches. Switch 3 will become root breeze, right? Now I wanted to configure switch 1 as a root breeze for VLAN 1 to 5, and I wanted to configure switch 2 as a secondary root breeze for VLAN 1 to 5, and for VLAN 6 to 10, let's say that I want to configure switch 2 as a root breeze and switch 1 as a secondary. Sure. Like I wanted to configure this switch 1 as a primary root breeze for VLAN 1 to 5, and for VLAN 6 to 10 I want to configure it as a secondary, right? On switch 2 for VLAN 1 to 5 I'll configure it as a secondary. For VLAN 6 to 10 I'll configure it as a primary. So it's very simple, as you have already done it in you have already done it in CCN as well as CCNP, right? Like here, spanning tree VLAN 1 to 5 root primary, then spanning tree VLAN 6 to 10 root. In same manner I'll configure the switch 2. So spanning tree VLAN 1 to 5
6 to 10 root. For 1 to 5 the priority, since all of them are running at the default priority, right?
Of course, but now they will change their priority.
Yeah, switch 1 will make it 2, 4, 5, 7.
For VLAN 1 to 5 only.
For VLAN 1
And switch 2 will also configure its priority, breeze priority as 2, 4, 5, 7, 6 for VLAN 6 to 10 only. Let me show you. So spanning tree VLAN 1 on switch 2. So it must not be a root breeze. And on root breeze its priority is what? 2, 4, 5, 7, 6, because VLAN 1 have also been added into it. That is why it have become now 2, 4, 5, 7, 7. Tell me.
Sorry, so why didn't it become a switch? This is switch 2, right?
This is switch 2. On switch 2 I said secondary keyword. I configured secondary keyword actually.
So root priority is 2, 4, 5, 7, 6, and bridge priority is 2, 8, 6, 7, 2.
This is root breeze ID, and this is breeze ID, means it's
of its
our
own.
own. Yeah, that is why I said that, because here for VLAN 1 on switch 2 I said secondary keyword, right?
I thought you were
So-
doing switch 1.
No, this is switch 2, right? That is why I have configured 2, 4, 5, 7, 7. Even here you can see that 2, 4, 5, like VLAN 1 have been added into it, right?
Yeah.
And this is the effect of secondary keyword 28672 plus VLAN ID. That's why it have become now 28673, right? So this is the effect of it. Now if you want to see it for VLAN 6 now, it means it is not having those VLANs here. Is it like that? So VLAN 3, VLAN 1 to 10. Now you will see show spanning tree VLAN 6. It must be configured as a root bridge now. Is not it? And you can see that it have configured as a 24576. Now if you move on like switch 3 or switch 4, and if you configure spanning tree VLAN 1 to 10 priority,
Now it will not change.
100.
Priority. It should be an increment of 4096.
4096, right? So now you will say like you can configure anything less than 24576, like you configure 20576. Oh, what was that?
Make it 8192.
20480, right? Lower than 24576, and again you will see that it will become root bridge for all VLANs.
Because it was already exchanged BPD.
See, root bridge 2, root bridge for 6, again root bridge for VLAN 8, also it will be a root bridge, right? But now if you want that, no, primary should be switch 1. Then you can do one thing, you can move again back on switch 1. You can say spanning tree VLAN 1 to 5 and again root primary.
But you need to negate the command above.
Yep. You see show spanning tree. I have not negated this command yet, right? So spanning tree VLAN 1. Check it out.
It became root.
And it have configured lower than 20476.
No, bridge ID is still yes. Correct. This is bridge.
Is not it? But here this time the effect of secondary keyword will not be there, remember. Or will there be? Like for an example, if I say spanning tree VLAN 6 to 10 root secondary. So let me show you spanning tree VLAN, like for an example 6. No.
Yeah, bridge
No.
ID is still 2.
So secondary keyword is not going to do work in this case, right? Only primary keyword can work. Fine. So in this way you can use primary and secondary. But remember, if you know that your switches, some of the switches are not having default priority, then you will never use this primary and secondary. In that case, you will always try to change your bridge priority manually. Fine. So now what can you do now? On switch 1, like a spanning tree, VLAN 1 to 5. Priority is what?
Yeah.
Sorry. And then spanning tree VLAN 6 to 10.
24096.
Any problem? Sure. Okay. But still, if anyone moves on switch 3 and configure its priority as 0, then finally they will compare their MAC addresses. And you know what, switch 3 is having lowest MAC address, and again switch 3 can become root. For that purpose, to prevent your switch network from this kind of attacks, you are having root guard.
Root guard could be a
Root guard.
Yeah.
I will be discussing it with you. Don't worry about that, right? But in this way, you can manipulate your root bridge election. That is same as like you learned during CCNP as well. Next is like what can they do? If PVST plus is running, they can say on both switches like no spanning tree VLAN 7, and there will be some users which will be participating in VLAN 7, right? So it can form now bridging loop. And they will never be able to form EIGRP or OSPF neighborship. I mean those two routers which are the member of VLAN 7, because due to this bridging loop.
and we'll see some flap.
Of course you can, like if I move back again on switch 1, you understand, and if I say like no spanning tree VLAN 7, it means show spanning tree VLAN 7. Is there nothing? Now you do one thing, interface fast Ethernet 1 by 0 by 1 switch port mode access and switch port access VLAN 7. In same manner I'll move on R2 and on interface fast Ethernet 1 by 0 by 2 switch port mode access switch port access VLAN 7, and then finally I can move back on R1 on its IP 0 by 0. Let's say IP address is 12.1.1. Now shut down. You will see that it will generate TC and BPDU switch 1 once its interface will come up. So spanning tree, it's aging time for VLAN 7. Let me show you, but VLAN 7 is not there now. VLAN 7 is not there, right? So that is why it is not showing you anything. Okay, leave it. Let's move on R2 now. On its FA 0 by 1, IP address is what? 12.1.2. They must be able to communicate with each other. It's not it, but still, see, without communicating itself, map flapping has occurred. It's not it. So you will see that R1 cannot communicate with R2. Of course, it cannot, because now there is a bridging loop for VLAN 7 only, right? You see. Now let me show you. Like if you are on R1, I can't run any single command here. See, I can't run. On R2 as well.
Lot of messages are coming.
Nothing. Now you do one thing, move back on switches and say spanning tree VLAN 7. See the performance of device due to loop only. And once you will say spanning tree VLAN 7, check it out. No problem. See, commands are running smoothly now. Even if you move on R1, working fine. So they can inject these types of faults during troubleshooting over there. Matthew. Ask. You are having something. Right? So now after it, let's talk about, like I was talking about, I think this
You were talking about 15-second it takes forward delay timer and all.
let me show you. This time show CDP enables. All devices are interconnected with each other, right? But this R1 is just connected to switch 1. Let me show you. Show spanning tree VLAN 1. This is root bridge, right? For VLAN 1. So spanning tree VLAN 7. This is root bridge for, no, this is not a root bridge, right? This is not a root bridge. And now let me show you. So spanning tree VLAN 7. Still its MAC address is in time. Now it have become, see, once again 300 seconds. Previously it was, because we made some changes here in VLAN 7, right? But again its aging time have become 300 seconds. On switch 2, so spanning tree VLAN 7. 300 seconds. So spanning tree VLAN 7. 300 seconds. Switch 4, so spanning tree VLAN 7. 300 seconds once again. Now let me show you. I will be on switch 1. I'll say debug spanning tree events. I'm going to shut down this R1 interface. I wanted to show you that if even its access port goes down, then also it will generate. Now spanning tree VLAN 7. MAC address in time is on switch 2. What is this? On switch 3. What is this? On switch 4 for VLAN 7. and again you will see that it will become 300 seconds. So it took took 30 seconds approximately, or 15 seconds to move back again on 300 seconds, because now there is no change, right? And in case if it comes up right, if it comes back up, right, if you move on R1 and you set no shutdown, again you will see that it will generate. Still it have not generated any TCN. You know why? Because it have not put this interface into the forwarding state. Whenever it will put this interface into the forwarding state, then it will generate TCN BPD, right? That is why still you can see that its MAC addressing time will remain as 300 seconds. Let it move into the forwarding state, then it will generate TCN BPD, right? Just wait for a moment. See, TCN, right? And for VLAN 7, for VLAN 5, see, is now aging. Is aging time is what, 15 seconds for all VLANs previously. Okay, so now on switch 2 also, okay, 22 was flapped actually. 22 was flapped. I don't know why, but 22 was flapped. That is why it generated. That's why it generated TCN for all VLANs. Here, this 22. Show interfaces. Sorry, show spanning tree once again. Okay, fine. Show spanning tree VLAN 7. Check it out. Now again, see, still it is having 15 seconds, right? And then after you will see that again it will become 300 seconds. Just wait for a moment. So is it really necessary for switches to generate TCN BPDU while their access ports goes down or comes up? Of course no, it is not necessary, right? So to solve this problem, what can we do? We can enable port fast feature, right? Like interface, fast Ethernet 1 by 0 by 1. I can see switch port, sorry, spanning tree. That's it. And this time you will see that I have already enabled debug spanning tree. I have enabled debugging here on switch 1, and now let's move back on R1 and let's shut it down once again, right? So previously when we shut down this interface, it generated TCN BPD, but this time it have not, right? Because it have not generated any TCN BPD. So for VLAN 7 you will see that its MAC addressing time will remain 300 seconds on all switches. Like if you move on switch 4 as well, configure this command, you will see that MAC addressing time will be 300 seconds only. So this is the advantage of configuring port fast feature. And another advantage will be, like now it will put this interface directly into the forwarding state.
Rather than going for listening.
Yeah, you can see. Show VLAN brief. Right? Even if it comes up again, let's move back again on R1, say no shutdown. I will show you that it will directly move, it will directly jump from blocking to forwarding, and it will not generate any TCN BPD. That is why again you can see show spanning tree VLAN 7. Its MAC addressing time will remain as. So by using port fast feature, you can also reduce unnecessary flooding of frames. Unnecessary unknown unicast flooding is not it, because MAC switches can flush their MAC entries from their MAC tables sooner, and if they flush the MAC entries from their MAC table sooner, then of course whenever, because end users will maintain their ARP table for a long time, so whenever next time they will generate any traffic, then switches will not be having those destination MAC addresses available inside their MAC table, so that they will perform flooding. It's not it. So this is the uses of port fast feature. So one thing, like you can enable port fast feature under interface
or default.
as well as you have another. My god, what is happening actually? 22
It's again flapping.
is flapping.
You can just because to
No problem. See, show spanning tree. So let me show you now the uses of uplink fast. Fine. Like for an example, here now no VLAN 1 to 10 and default interface fast Ethernet 1 by 0 by 1 here on switch 1. The same command I'll configure on switch 2 as well. Default interface fast Ethernet 1 by 0 by 1. So yeah, I was telling you that you can also enable port fast feature in this manual as well. Spanning tree port fast default. So what do you mean by this default
enable
command?
all the access.
Access port automatically, right? This command will not force this switch to enable port fast feature on trunk ports, right? This command will, I mean, by configuring this command, now port fast will get enabled only on access ports. And to understand, I mean, to confirm whether this default port fast feature is enabled or not, for that
Show
show
interface fast
show spanning tree summary. This command will tell you that whether this default port fast feature is enabled or not.
In show interface fast Ethernet 0/0 switch port, will it show something like related
Port
to
fast feature show interface fast Ethernet 1 by 0 by 1.
switch port?
This port is not going to show you anything related to port
So you can
fast
just include
because this is all about the switch port only, right?
Single switch port is port fast. The last word.
Okay.
Same command but last word port fast.
oh,
Switch port and then
instead of switch port.
Instance for switch.
okay, then you can this port fast.
Yeah.
Yeah, the command itself is not.
Port fast.
No.
Control.
That is show spanning tree summary. It shows,
Just spanning tree.
yeah, that there
Summary.
I know it shows.
From here you can see the default, right?
No, shows spanning tree interface port.
Yeah, then say like that. Show spanning tree interface fast Ethernet 1 by 0 by 1 and then port fast. Here you can see.
Oh, okay. So we have enabled it directly, but will it show it on the other one as well?
Where? On switch? Another switch? No, it's not VTP.
No, not on the other side. Say for example, we enabled it on all the.
Let me show you. Like for an example, if I move on R2 now, and on R2 I will say FA0 by 0 and then
No shut.
no shut. And before running this command, again I will come back on session and I will say debug spanning tree events. Let's move back again on R2 and say no shutdown. You will see directly it will move from blocking into overload. See,
So it took the port fast.
of course default. I mean it, but remember that it will be applicable only for access
Yeah,
ports,
can
not
you
for
just
trunk ports.
type for the fast it's from /0/2.
Yeah, sure, for sure. It will show you that it is enabled.
Okay.
Right, so now it has been enabled. I mean, we have enabled this port fast globally now. So in exam, if they say that okay, with using single command, enable port fast feature on all access ports, right? So you will be using this command only. And to confirm it whether this default command is enabled or not, show command is show spanning tree summary. From here you can see that port fast default, right? So it is now enabled. Fine. So in this way you can configure it. Now let me tell you the uses of uplink fast. So what can we do? Again, I'll shut down all other interfaces to show VLAN briefing bit. I mean, I'll be connecting switch 1 and switch 2 only, right? So interface range fast Ethernet 1 by 0 by 19 to 20. And then
Fast, we need a direct same notification where at least one of the ports should be in the ground alternate.
exactly that's what I'm having here. Like 19 and 20 are there, right? So same command I'll configure on switch 2, right? Now you see that switch 2 is not a root bridge actually, show spanning tree. You see that switch 1 is a root bridge and this 21 is configured as a root port now, right? Okay, in case let me show you debug spanning tree events. And one more thing that I would like to show you here, because like spanning tree port fast default, I'm also enabling this feature here as well on switch 2. And let me do one more thing. Oh my god, this 22 is We have to do something so that we can perform all this practical. Only cable was the issue actually. Okay, just spanning tree. Only variant 1 is running here, right? Port fast feature is already enabled now. And now I'm gonna to draw this diagram in this manner actually. Like I'm having only 2 switches here. And switch 1, switch 2. This is something like this. 0 by 21, 0 by 21, sorry, 22. 0 by 21 and this is 0 by 22. Here R1 is there, this is R2. R1 0 by 0 is connected with switch 1 0 by 1. R2 0 by 1 is connected with switch 2 0 by 2, right? Both of them are in same VLAN 1, right? And the IP address is going to be 12.1.1 here, and here it is already configured 12.1.2, right? So they must be able to communicate with each other. Let me show you. So let's first of all let's see the output of switch. Let me show you. See 21, right? Then let's move on. R2 do show IP interface brief actually. Let me show you the IP addresses. Yeah, that's fine. And if it's 0 by 1, yeah, that's fine. Show CDP neighbor. R2 must be connected with. How is it possible? Okay, I configured I think IP address on. If it's 0 by 0, shut it down. Show CDP neighbors. What is this?
We have made it on fastness 0/1 and
Yeah, and inside CDP neighbor it is showing me my local interface is FA 0 by 0. My God. Only R1 is connected, that's fine. Show CDP neighbor. R2. And on R2 still it will be showing you 0 by 0. Yeah.
And it is not showing it is connected with switch 2.
Yeah, it is showing me switch 1, but switch 2 is showing me that it is connected with R2.
So how why
Show CDP neighbor. Let me do one thing. No CDP run. Show CDP neighbor. Nothing. CDP.
suppose there will be negotiation and now it will be sound but root was the customer will ask why was it happening? What should I do that it should not happen next time?
Anyways, this time it should show switch 2 only. Okay, no problem. Let's move again back on switch 2 and first of all, very first thing, let's show William brief. This 0 by 2 must be member of. Okay, then we have to say default interface fast Ethernet 1 by 0 by 2. Fine. Show William brief. That's fine. And on switch 1, 0 by 1 must be member of VLAN 1. It is already. So from R1, let's try to communicate with 12.1.2. It must be. See, from R2 you can also try to communicate with. Fine. Show CDP neighbor. This time it is showing you correctly, right? Switch 2 only. Okay, now see, ping 12.1.1, repeat. We'll keep on to communicate with switch 1 now. See? Okay, let it be. Let's move again on switch 2 now. Show spanning tree. How to say debug spanning tree events now to show you that okay, it will take at least 30 seconds to move into forwarding state, right? Now let me do one thing. FA1 by 0 by
design the topology. Yeah, it is okay.
This is 21, right? I'm going to shut down this interface now on switch 2. If I shut down this interface, you will see that 22 will take at least 30 seconds to move into forwarding state. Till that, R2 R2 will not be able to communicate with R1. So R2 has to drop at least 15 ICMP packets.
Yeah.
Because ICMP echo reply timeout is what? 2 seconds. So still it is communicating perfectly. But now let's move on switch 2 and on 0/21 switch down. You will see that, see, 22 have immediately moved into listening state, but data will not be forwarding. See, it is not forwarding data. So at least, this is kind of direct topology change, right? So as I said, that the convergence time for direct topology change will be at least 30 seconds, right? So of course, for next 30 seconds, there will not be any communication between the users behind switch 1 and switch 2, as you can see here as well. Now, it means that on switch 2, it have moved into the forwarding state. Even you can see that at sharp 34:41, it moved into listening state. At sharp 35:11, which is like 30 seconds. It's not it. It took sharp 30 seconds to move into forwarding state. And here also you can see that how many packets were dropped, like 3, 4, 5,
15 it will be around approximately.
3, 5, 5, 10, and plus 5, 15. 15 ICMP packets were dropped due to
STP.
connectivity loss, right? Due to outage in your network. Fine. So to solve this problem, now what can we do? I will move back again on switch 2, interface FA0/21, and then I'll say no shutdown. And one more thing, the most dangerous thing is like this, that in case if it comes back up again, right?
Again,
Again it will take 30 seconds. See, now 21 jumped into forwarding state because it didn't knew that it is a trunk port, right? It was thinking that it is an access port. That's why it jumped into forwarding state. When it came to know, no, it is a trunk port. Again, it moved back into listening state. See, until that there will not be any communication. This is the dangerous thing about it.
22 which was acting as a forwarding, and that
First of all, it thought that 21 is an access port because port fast default feature was enabled, so it directly put this interface into the forwarding state, as you can see here, right? But then later on it came to know that okay, it is a trunk port, so it moved back into the listening state from forwarding state.
yeah, but the 22 one.
Yeah, 22 will directly move back into the blocking state again
So shouldn't
at same
20
time.
Yeah, but shouldn't 22 actually be moved to blocking state after the 21 moved to forwarding state?
So it has done actually. Still say 21 is not in forwarding state now. 21 is in listening state.
Listening state.
Mhm.
But ideally, after enabling the port fast, after enabling the uplink fast,
There is no uplink fast now.
right, after enabling uplink fast, this
Mhm.
22 which is in blocking, which moved to blocking state immediately, the switch one turns into a listening.
That will be different thing. That will be different concept, right? I'm not talking about the uplink fast. I'm not talking about those states which will come after enabling uplink fast. But right now, you can see that if you do not have uplink fast feature, right? So if you're 21, if your primary root port goes down, then secondary root port will take at least 30 seconds to move into the forwarding state. And again, if your primary root port comes back up, right? Again, it will take 30 seconds to converge, right?
It's taking more than 30 seconds.
Yeah, of course, it will be taking
More than 30 seconds. Look at the timestamp.
like 18 and yeah, like 32 seconds.
More than 30 seconds.
32 seconds.
4.
34. Yeah, 34 seconds. So that's the biggest problem now. That's the biggest problem.
Yes, because.
But one more thing. You will calculate it. Hey, guys. You will calculate it from here when 22 moved back into blocking state.
Because the forward is still.
Yes.
Forward and move back.
Right? Because if 22 is in forwarding state, till that it will keep on to forward data, forward traffic, right? So at 23 it moved into the blocking state, and then after, as you can see, like Approx 30 seconds.
No, it should be from 22 because at 22,
Why?
because the 22.
I'm not talking about the. I'm talking about the convergence time. I'm not talking about that how much time taken by 21 to move into forwarding.
Yeah.
I'm talking about the convergence time.
Convergence time. Since at 22, this fast Ethernet join slash 0/21 move from blocking to listening state. Right?
Hey, you will always calculate the timer from where your communication was blocked. So your communication, your traffic was dropped from this timer because it moved. This 22 moved into the blocking state at this time. Till that, it will keep on to transmit your data.
Yeah, it will keep on because the fast Ethernet 1/0/22 was in forwarding state, right? But the states, one particular port has 3 states, like listening, learning. So at 22, it moves to listening.
Doesn't
state.
matter that what was happening with 21, right? Because 22 was already in forwarding state, so it was sending your data, right? Your data, your traffic was going through the 22 actually.
No, what I'm trying to say is that it behaved correctly and it moved from 22 to 52, not from 18 or 23. Because 22 went into the listening state at 21 went into the listening state at 22.
Yeah, of course. That's why it took like 30 seconds up to forwarding state, right? But communication was blocked from this time.
Yeah, of course. The communication was blocked from this time.
Right? So it's working fine now.
Yeah.
And now let me show you. Okay, one more thing here. Let me stop it first. And once again, I will start this communication. Right? And it is working fine. There's no problem at all. And on switch 2 also shows spanning tree. That's fine. That's 21 have again become the root port, right? I mean primary is 21 actually. And then after I'm gonna to enable uplink fast feature now. Spanning tree, uplink fast. After enabling this feature, you will see shows spanning tree.
So it should be enabled since these are only the 2 switches, right?
A spanning tree, I mean this it have not been enabled actually.
Shows.
Tell me why. Uplink fast is not enabled. Because if uplink fast is enabled, it must have shown me here that uplink fast is enabled. However, if you say show spanning tree, uplink fast, then it will show you uplink fast is enabled. But it's not gonna do work. It's not gonna do work. Let me show you that it will not work here. You know why? Let me show you. Debug spanning tree. Sorry, events. If I shut down this f0/21, step by step. It's not it. Till that, no communication. Because uplink fast was not functioning. You know why? Because this, as I said, the primary requirement for it that at least, I mean, the switch must have its default breeze priority. Switch must have its default breeze priority.
Okay. Yeah.
But this switch was having 4096 actually for this VLAN one. So first of all, you have to remove that command from here. Let me remove that command from here, and I will simply remove only that command. Oh, where is that? No, it have not been.
You can just do show run include.
Just wait. This is no. Just let me show you now. Uplink fast will get enabled. It's not it. Just after configuring its priority as default priority, now uplink fast has been enabled automatically, right? And then after, because 21 is the primary root port now, right? So spanning tree, uplink fast, even it will show you that okay, uplink fast is enabled now, right? Now debug spanning tree events. Let me show you one more thing that still traffic is going without any problem. Interface fast is enabled by 0/21. Let me shut down this. Just after shutting down it, you will see that is there any problem? Traffic is going perfectly right. Let me stop it now. But at least one packet will get dropped. There was some outage. So even after enabling uplink fast feature, there will be some outage, but it will be brief outage. And users will not be able to experience this kind of outage. Yeah, but if like there are some applications like you are talking about voice data, so for that moment only might be that your voice-based traffic will not be delivered, because voice-based traffic will be delivered within milliseconds. So if there is some delay more than milliseconds, then of course it can cause a big problem, right? So for that type of for that type of network, of course you do not have anything to do here, even after enabling uplink fast as well. So this is the role of uplink fast. And another thing is also there. You know what is that? Like for an example, if you are communicating previously, if primary was coming back up, again it was taking 30 seconds, right?
Now it is not.
But this time it will not. There will not be any connectivity loss actually. Still it will take 35 seconds. Primary root port will take, like if you have, if your primary root port has gone down, right? And again if primary root port comes back up, it will take 35 seconds. But during those 35 seconds there will not be any connectivity loss. Let me show you.
Can you just show? I just need to read these debugs. So as soon as you enable uplink fast, you
See,
shut down the switch.
I'm going to shut down this interface now. And uplink fast is enabled on this switch too, right?
Yeah, so I just wanted to read the debug for when you shut down. So when you shut down, this 22 was elected as a new root port automatically and
Immediately
moved to forwarding.
Immediately.
Okay.
Now you see,
The 21 will
21.
be moved to forwarding state.
let me show you. It moved directly from
Blocking.
jumped from blocking to forwarding. You know why? Because it thought that it is an access port, but later on it came to know that it is a trunk port.
Yeah, but
And if it is a trunk port, then again it have moved back into the listening state.
yeah, but then
And immediately it have started this root port delay timer, which is for 35 seconds.
yeah, but till that time 22 was still.
Of course. You see, communication is there. Still, it is communicating with that. Yeah, it is already. 22 is still in forwarding state. Once 22 will move back into the. You see, now they have interchanged it immediately, right? And there is no droppage, right? There is no connectivity loss. But
One packet.
one packet. Yeah, there is.
Yeah, the above.
This is.
Why does it drop? GPD?
Because at least it will take some time to.
It's
Yeah.
interchanging between.
So that's the only thing.
So since there are only two switches, you configure it on switch 2. But in case if there are so many switches and if you need to configure uplink fast, you need to configure it on all those switches where you have at least one port as
Alternate
port, right?
If you do not have any alternate port, then of course there will not be any advantage of enabling this uplink fast feature. Fine. So this is the uses of uplink fast feature, and I have also shown you that how does it perform actually. I have also taught you that what is the meaning by this root port delay timer. It is by default 35 seconds, as you can see here. From here 28 plus 35, it will be in forwarding state. Check it out. 28 plus 35.
So during this period, what's happening?
Like you have configured ether channel, PHEP negotiation, DTP negotiation, and all. But it will assume it, right? It's not like if PHEP is there, then it will change its timer. Because you will always create a standard technology, right?
Mm-hmm.
It is not like that if PHEP is configured, then it will take 35 seconds. Yeah, that's why by default it is 35 seconds. So that within 35 seconds it can perform all that kind of
What
negotiation.
was that timer?
Like you know very well that by default, if PHEP is there, PHEP will also take some time to negotiate ether channel as well, right? It can take like 5 seconds and more than that, right? And 30 seconds are for listening and learning state.
So that is root delay timer.
Yeah, that is root delay timer. And it is good actually. It is good because if primary is flapping, I get my point. If primary RP is flapping, then how will you identify it? Because if it comes up, again it will become root port. Will go down, again secondary will become root port. Will come up, again primary will become root port, right? So this is good actually. Right? So in this way it will work. Then after, let me show you the uses of backbone fast. Is it really necessary to go for that backbone fast? I think you can. I will require to have 3 switches. it is mandatory to draw that diagram. I mean, I must be having at least 3 switches to perform that practical.
Indirect topology chain notification.
Yeah, of course. Like in previous class, I taught you that okay, if like switch 2 was not having any alternate port, switch 2 lost connectivity with switch 1, then switch 2 became as root base, it started to generate inferior BPDU. Switch 3 waited for 20 seconds, right? Then after it switch 3 put that blocking port into listening state, right? Then again listening,
It
learning.
needs to be enabled on all the switches.
Backbone fast, backbone
Yeah,
fast,
backbone fast.
but uplink fast is not necessary to enable on all switches, right?
And
But
then
backbone
you
fast
send the
must be
root
enabled
link
on all.
query to the
Exactly, like in backbone fast, you are having 2 types of messages. One is root link query, and one is root link response.
Yeah, and once you enable backbone fast, you will get the RLQ response
Exactly,
immediately.
exactly. Root link query request, root link query response. There are 2 types of messages available in backbone fast. I mean, in backbone fast feature. One more thing, if you have not enabled backbone fast feature on any one of these switches, and if that switch receives any root link query request or root link query response, it will simply drop that. That is why we always say that okay, backbone fast must be enabled on all switches, right? So this is the only reason, so that it should be enabled on all switches. So now you tell me please, if should I require to go for backbone fast as well, like I perform this uplink fast. Okay, so let's do one thing now. Let's go for STP protection.
Yeah. Root guard.
Yeah, root guard, right? First of all, let's talk about the root guard only. However, generally we do not prefer to use all these things like root guard. Yeah, of course, loop guard is needed, but after launching UDLD, there is no more requirement of enabling root guard. Sorry, loop guard, right? So let's start from root guard itself. As I said, that if you have configured switch 1 as a root bridge, right, and you configured its bridge priority lowest one, which is 0. But someone else configured their bridge priority as 0 as well. Then final decision will be based on their MAC addresses. Might be that if your switch is oldest one, of course it will be having lowest MAC address, right? So of course your switch can become root bridge, and if your root bridge have changed, it means entire data flow will get changed.
Yeah.
So if you want to prevent your switch network from these type of attacks, then of course you can use this root guard. But remember,
DP.
DP. You know why? What is the rule of DP in STP?
It sends the
Transmits the BPD. It is never desired. It is never expected actually to receive any BPD on DP, because if you receive BPDU message on DP, it means it will immediately lose its DP state.
Yeah.
I mean, if it receives any superior BPD, right, on its DP. I mean, if DP receives any superior BPD, then it will immediately lose its DP state. Remember, but it must receive superior BPD. What is the meaning by superior BPD?
With the higher
With the lowest, I mean, with the best bridge ID, right? So if DP receives any superior BPD, then it will immediately lose its DP state. But here, after enabling root guard on DP, remember that you will enable this root guard only on DP trunk ports, right? So if you enable root guard, if you configure this root guard on DP, then after, if it receives any BPDU message, then it will directly move into root inconsistent state for that VLAN only, for which it received that superior BPDU. It will move in root inconsistent state only for that VLAN, because if it moves into error disabled state, it means it will move in error disabled state for all VLANs, because error disabled state is not like per VLAN or something like that. If your switch port moves into error disabled state, it means it will move in error disabled state for all VLANs. But here, it will move into root inconsistent state. Now the question is, what is the difference in between root inconsistent state? I mean, what is the difference in between inconsistent state and error disabled state? Like in inconsistent state, your port can recover automatically once your problem will get resolved. But if your switch port has moved into error disabled state, then it will always remain in error disabled state unless you don't reset it manually. Like you will require to shut it down manually, and then you have to, or you will require to configure error disabled auto recovery or error disabled recovery, right? So this is the main difference in between inconsistent and error disabled. And one more thing, like as I said, that your switch port will move in inconsistent state for a VLAN, for a specific VLAN, but switch port will move into error disabled state for all VLANs. Fine. So these are the differences. So now let's say you are having this kind of network, like this is switch 1, this is switch 2, this is switch 3, you understand? This is root bridge, so it's going to be DP, RP, let's say this is DP, and this is what? Block. Now behind switch 2, someone added this new switch with lowest bridge ID. So if this switch becomes root bridge, then of course it will become DP here, it will become RP, and then it will also try to send BPD messages in the direction of switch 1 as well as switch 3. But here, because it is already configured as DP, so you will enable here root guard. Here it is already configured as DP, here you will enable root guard. So after enabling root guard on these interfaces, if they receive any superior BPDU, then they will immediately put that interface into inconsistent state for that specific VLAN only for which they received BPDU messages. Got it?
So for till that time there will.
And one more thing, but for switch 2, of course, this switch will be root bridge. But for these two switches, switch 1 will remain as a root bridge. So remember that it does not provide you 100% security.
Yeah, but so for till that time,
Mm-hmm.
the connectivity, since it will be in the root, I mean, this DP will be in the root inconsistent state.
Mm-hmm. Of course, till this switch is announcing itself as a root bridge. Once this switch will stop to announce itself as a root bridge, then these interfaces will move into that, into normal state dynamically.
So in the root, basically what my question is, in the root inconsistent state there will be no data.
Of course, but only for that VLAN, not for all VLANs.
So at least we know where the problem.
Exactly.
Will it generate any log as well? That like in the
Yeah, it will. Let me show you. Let's say this is switch 1. Just spanning tree, you know very well that what is happening here. And this is also, let me disable uplink fast here. Spanning tree, uplink fast, just spanning tree, no problem. Now let's do one more thing. Let's configure this priority as 4096 now. Spanning tree VLAN 1 priority is what? 4096. So it will remain as root bridge because switch 2 was having default priority, right? So switch 1 will remain as root bridge. There will not be any problem. And then after, because I know that okay, these two ports are DP, right? So on these two interfaces, interface with fast Ethernet 1x0x21 to 22. You understand? And then I would say spanning tree guard is what? Root. Remember, root guard cannot be enabled globally. Root guard cannot be enabled globally. So now show spanning tree to see whether root guard has enabled or not. Show spanning tree interface fast Ethernet 1x0x21 and then detail.
So what would have happened if we would have configured this root guard instead of DP on all the switch on all the ports?
The meaning by DP, if you enable root guard, it means then after you must not receive any BPD on that interface. So it will move into root inconsistent. Sorry, yeah, of course, root inconsistent still. I will show you, don't worry, right? So here I've enabled now root guard even on 0x1x22 as well. Root guard is enabled now, right? Then after, let me move on switch 2, because for switch 2, switch 1 is working as a root bridge. But then after, I decided to configure the switch 2. I'm an attacker, right? If I am an attacker and I configure the switch 2 as a root bridge now, I try to configure it, right? Like I said, spanning tree VLAN 1 priority is what? 0. So now this switch 1 will become root bridge. It's not it, but this time, check it out. For only VLAN 1, remember. Just root inconsistent state, right? And one more thing, if you are having like VLAN 2 as well, show VLAN brief. Of course, VLAN 2 is there now, and show spanning tree. Let me show you. For VLAN 1 only, these two interfaces are in root inconsistent state, but for VLAN 2 there is no problem at all. Even if you move on switch to show spanning tree VLAN 2, no problem at all. Yes, root port is still 21. because I didn't configure this priority as 0 for VLAN 2. I configured this priority as 0 for only for VLAN 1. Right, so I hope that now you have understood the uses of root guard. Fine. But remember that, however, the switch 1 have put 21 and 22 in root inconsistent state for VLAN 1. Traffic of VLAN 2 and all other VLANs, right? Traffic of all other VLANs will still be allowed through these trunk ports. There will not be any problem for other, for all those users which belongs to, other VLANs. Matthew, any problem? Tell me, root guard.
Can you just drop?
Yeah, now let me do one thing. Like you asked me that question, that can't we enable this root guard on all switch ports? It's not possible. Remember, it will be this feature root guard will get enabled only on DP, and I will also tell you one another condition for it. Let me remove it from here. Interface range fast Ethernet 1 by 0 by 21 to 22, and let me say no spanning tree. Then after no spanning tree, and it was guard to root, right? So I have disabled it now from here. So spanning tree, of course there will not be any problem, and now switch 2 will become root bridge. Let me do one thing. Let me say no spanning tree, priority 0, something like that. So spanning tree, and there is no problem actually. This it must not be actually. It's happening.
What do you have on switch 1?
That's good. Yeah. Then, because on switch 1 it is now 4097, right? That's why switch 1 have become root bridge. Alright. Then you said that can't we enable this root guard on all interfaces? So let's try to configure it here. Interface range fast Ethernet 1 by 0 by 21 to 22. You understand? And then I'll say spanning tree guard. Happy.
Guard enabled on. So
And also it have put these interfaces into root inconsistent state for both VLANs. Let me show you.
both VLANs, there is only one VLAN.
VLAN 1 as well as VLAN 2. I also configure this VLAN 2. So remember, this feature must not be enabled at the end of non-DP.
So we have configured it on non-DP, and it automatically receives it to the root inconsistent. So it receives superior BPDU and immediately it put into the root inconsistent.
Simple.
Can you just explain the operation of what happened now?
What?
Explain what happened now. Like now.
Yeah,
Nothing.
After enabling this root guard. Explain the operation of what happened.
because switch
No, actually he wanted to ask.
Yes, that's what I'm saying. Like
Nothing will happen now. Communication will not be allowed. You have blocked everything now. You have thrashed your network.
yeah.
So remove it now. See, root guard must not be enabled at the end of non-DP. If you enable it at the end of non-DP, because non-DPs will always receive BPDUs from DP. So if you suspect that okay, on this interface you can receive BPDUs in future also, then never enable root guard. And that is why it is also recommended that in case of load balancing, that if you are using PVST, it means you will also configure load balancing, right? Like for in some cases, one switch 1 will be root bridge for some VLANs, switch 2 will be root bridge for some other VLANs. So one single port will be either will be DP for some of the VLANs and can also be non-DP for some other VLANs too. Are you getting my point?
Yeah.
Single switch port can be DP for some VLANs and can also be non-DP for other VLANs, right?
Yeah.
So if something, if it is happening something like that, in that case you will never enable this feature on that switch port, never ever. Because whenever it will receive any BPDU, it will directly transition your switch port. It will directly transition your switch port in root inconsistent state for that specific VLAN. And one more thing I would like to tell you, you cannot enable this feature under interfaces for some VLANs only, for a specific VLAN. That is the problem. You cannot enable this root guard feature for some specific VLANs only under interfaces. No. If you enable this feature under any interface, then it will get enabled for all VLANs. So in case of load balancing, again, you cannot enable this feature. That is why in live networks you will, normally you will never get this feature done, or this feature available on switches. Of course, you will never get it. You will never find it, because generally we avoid all these things. Yeah, you will definitely find BPD guard and BPD filter enabled on all access ports. On all access ports, it's really mandatory.
To prevent further trunking.
To prevent not from trunking only, even
And to detect any switch.
actually, like even if your port is access port, then also it allows the BPDUs for one VLAN only, right? Which is configured on that access port. So sometimes what happens, that might be that you will be receiving BPDUs for that specific VLAN. Let me show you. For an example, this is like switch 1. This is switch 2, and this is host, right? And
What happened?
I'm not touching it, but it's writing.
Oh.
Sometimes it happens. So if this is switch 1, I'm not touching it, see?
Let's use the marker instead of this.
It's not making noise, Okay, so in this way, if your connectivity is in this way, right? So let's say this access port is in VLAN 10, right? So still this switch can transmit BPDUs of VLAN 10 out from this access port, right? And also can receive BPDUs by default for VLAN 10. So might be that if this user have become now attacker, and it have started to generate BPD messages for VLAN 10, and if it is generating BPD messages with lowest bridge ID, it means it can become now root bridge for VLAN 10. So it is really necessary for us to enable some security feature on this access port. And the best feature is BPD filter, as you know. I'll be discussing it with you, that why BPD filter is best rather than BPD guard.
BPD guard puts it in the error disabled state. BPD filter stops and sends receives the BPD, right?
So which one is better?
Filter.
Why?
It will not put it into the error disabled
It's
state.
not like that. You cannot say that BPD guard is taking BPD guard is putting your interface into the error disabled state. That is why BPD guard is not good and BPD filter is.
Because in BPDU guard,
See, in case of BPD guard, what happens that it will take an action against the received BPDUs only, right?
Yeah.
But it will never stop all outgoing BPDUs.
But if it
Never ever.
right, but if it will put it in the error disabled, right? How will it send the BPD?
I'm saying that, let's say that this user is not generating BPDUs, but still it can receive BPDs and it can get information coming from your switch. Is not it? If it capturing BPDUs coming from this switch. Hello.
I didn't get it.
I said that here this is the root bridge for VLAN 10 now, right? So it will generate BPDU, will give it this switch 2, and then switch 2 can also transmit these BPDUs if BPD guard is enabled, right, towards this PC. So this PC, if this is an attacker, right?
Yeah.
An attacker is sitting on this PC. It can capture those BPDUs and can get your switches information. It's not it.
Yep.
But if you have enabled BPD filter,
No.
if you have enabled BPD filter, it will never transmit
If
BPDUs.
this is an attacker, it is just listening.
It is not generating BPDUs.
Oh, okay.
So for that purpose, BPD filter is better than BPD guard.
It will not send and receive.
Exactly. If it receives it, it will ignore them, and also it will stop all outgoing BPDUs as well.
Yeah.
So, okay, leave it. So I was telling you about the root guard, right? So remember that root guard must be enabled only on that interface, which is DP trunk for all VLANs. If your trunk port is non-DP for any single VLAN, then also you will never enable this feature on that interface. Fine. Then after talking about the root guard, because I have also proved it now, right, that how does it really function. Like for an example, again, if you said like you enable it on switch 1 interface links fast Ethernet 1 by 0 by
It put into the root
21,
interface. As soon as it receives
spanning tree guard, fine, and then after you can move and on switch 1, you can see spanning tree VLAN 1 and radius 2, and again you will see that switch 2 would put, so switch 1 will put these interfaces into root inconsistent state. Let me show you for VLAN 1, root inconsistent state. But once you will remove this command from switch 2, once the switch 2 will stop to generate BPD messages, then again you will see that you will not require to do anything at the end of switch 1. It will automatically put these two interfaces into normal state, right? Let me show you. See, unblocked. Simple. This is the advantage of having inconsistent state over error disabled state. Second thing, as I said that generally we will not prefer to enable this root guard in the network, because most of the time you will find load balancing in your network, right?
Yeah.
Right, one interface will be DP for some of the VLANs, and same interface can also be non-DP for the same some of the VLANs, right? So you will never enable this feature on all those interfaces. That's why we do not prefer to use this feature of STP, security feature of STP. Next is what? Loop guard. Like we says that STP prevents our switch network from the bridging loops, but still there are some possibilities of forming bridging loops as well. Like for an example,
BPD
if this is switch 1, switch 2, switch 3, 0 by 1, 2, 1, 2, 1, 2. You understand? And let's say MAC address is A, B, C. It's going to be DP, it's going to be DP, RP, RP, DP, block. You understand?
Yes.
Now, in case, for an example, let's say that in between switch 1 and switch 3, this time, I'm not saying that interface has gone down. Due to some reasons, because it is always expected to receive BPD on its non-DP, right, on switch 3, because it is primary RP, right? This is primary RP root port. However, it is also having alternate port. But the thing is, primary root port is what? 0 by 1. So it is always expected to receive BPDUs in every 2 seconds coming from root bridge, right? Now let's say interface is up, but now switch 3 has stopped to receive BPDUs coming from switch 1 on its RP. It has stopped.
Why will I enable BPD filter?
Whatever it is, whatever the reason, right? Might be it is like iOS bug or something like that. Whatever it is, but finally, the switch 3.
Switch is already.
That's what.
Switch 3 have stopped to receive BPDUs coming from switch 1 now. So there can be any reason, right? So if switch 3 stops to receive BPDUs on its 0 by 1, maxes of superior BPDU is what? 20 seconds. It will wait for 20 seconds now, right? It will wait for 20 seconds, and after 20 seconds, because it will lost its non-DP state. It will lost its non-DP state because now it have stopped to receive BPDU on this interface, and the maxes timer of BPDU is what? 20 seconds. So after 20 seconds now it will put it into the listening state, you understand? And finally it will become RP. And because on one switch you cannot have more than one RP, and because it is also not receiving any BPDU here, so automatically it will become now DP. Hello. It will automatically become DP because it is not receiving any BPD on this interface, right? And I said as earlierly, I have already taught you these things, that in a single segment both ends cannot be either DP or RP, non-DP, right? If it is something like that, it means there is a bridging loop. So now because both ends will become DP, and now there can be a bridging loop. Is there any interface which is in blocking state now? So they can form a bridging loop. Have you understood it now? So there is no solution in STP for this type of problem. For that purpose, actually, we are having loop guard. And this kind of problem can occur due to sudden loss of BPDU, right? This type of problem can occur due to sudden loss of BPDU, right? So to prevent your network from bridging loops due to sudden loss of BPDU, we are having a solution of it, which is loop guard. So we can enable loop guard here. But remember, loop guard will always enabled only on non-DP. Only on non-DP. You will never enable this loop guard feature on DP, designated ports, right?
Yeah.
Okay, now because it was working as a RP earlier on, right? So you will enable loop guard here. You will also enable loop guard here because it is blocking. It means it is also non-DP. I'm saying that loop guard will be enabled on all non-DP, and under non-DP you have both of them, blocking as well as RP, root port. Is not it? And after enabling loop guard, if you do not receive BPDU for any VLAN, right, it will immediately put that switch port into loop inconsistent state. Now let's say it was RP, and now it have stopped to receive BPDUs coming from switch 1, right? So it will put this interface now into loop inconsistent state. You understand? And if this switch port moves into, if this switch port becomes RP and moves into forwarding state, then there will not be any loop, because switch 3 has already put this interface into loop inconsistent state. And if your switch port is in loop inconsistent state, it means it will not allow your traffic, your data. Have you understood it now? So this is the solution of this kind of problem. So now to implement it, what can we do here? Let's say that this is switch 1, and let me do one thing, no VLAN to actually come here, show spanning tree. You will find only and only VLAN 1, and both of them are working as a DP. Now let's move on switch 2, so spanning tree, and on switch 2 I think I have switch 2. What is happening? I've removed it now, right? And also I'm going to remove it from switch 1 as well to show history. I'm going to remove it, right? So now you see, show spanning tree, everything is fine now. 21, 22, both of them are up. Even on switch 2 also, both of them are up. 21 and 22, both of them are up, right? Okay. Now let it move into the forwarding state first. Then I will show you that, okay, they will be communicating with each other, right? I'll show you. Right? You see, they are communicating with each other without any problem, right? Now let's do one thing. Let's move back on switch 2 and let's try to perform this practical now. So how will it be possible for switch 2 to do not receive BPD on this RP if we enable BPD filter on DP? It's not it. If you filter, if you configure BPD filter at the end of DP, it means DP will stop to generate BPD messages, right?
Even if we enable it on here, it will not receive BPD, right?
Yeah, but it will, it will become then, yeah, you can do whatever you want, right? So we can move on switch 1 and on interface FA1 by 0 by 1, I can say spanning tree card is, sorry, BPDU
filter enabled.
Right? Once you will configure this command here, let me show you, debug spanning tree events. So spanning tree, you will see 21.
It will after 20 seconds.
Yeah, after 20 seconds, right? It will lost its RP state. and still there is no problem. See, related to communication, fine. 22 has moved into listening state, but the thing is there is no problem related to communication because still port is there, right? Port have not gone down. Port is still there. See, it shows spanning tree, but it have become now DP. So both ends now have become DP. Here it is DP. If you move on switch 1, then also you will find that it is working as a DP. Let me show you 21. So both ends are working as a DP now, and now you see that all of them, wow, have become into the forwarding state, right? And flapping have also occurred, and if flapping is there,
You cannot even access.
see, I can't do anything now. I can't do anything. So there is a loop, breathing loop now. To prevent,
21 become DP
yeah,
because you enabled BPDU filter on 21 of switch
yeah.
1. So switch 1 will not send any BPDU.
And also if switch 2 is sending, because now switch 2 will also send BPDU towards switch 1.
Because
Switch 1 is not
not-
going to process them.
So this become root.
Both ends of this segment have become now DP. Tell me.
And what? Can you show me the diagram?
Sure. Switch 1 and switch 2. 21, 22, 21, 22. It was root breeze.
Yeah.
I have enabled filter here.
Yes. So it will not send this.
So
because
it is DP. It is also DP. This is DP and this is what? RP.
So the 22 remains RP.
Of course.
Okay, only that.
You move from blocking to RP.
It moves
Yeah.
from blocking.
Yeah, 22 moved from blocking to RP. Because this 21 lost its RP step.
Yeah, exactly.
Because it didn't receive any BPDU coming from switch 1 within 20 seconds, which is the maximum timer of.
So it will the 22 will start receiving BPDU.
Of course, it is still receiving. Because I enabled filter here only on 21.
Yeah. Okay.
So on 22 it will keep on to receive BPDU. That's why it will remain as RP. And because it is receiving BPDU, so it will think that okay, I should send a copy of those BPDU out from 21. That is why it have become DP. But switch 1 is not processing that
yeah.
due to BPDU filter. So there is a loop now, right? To solve this problem now, what will I do? I will again move back on switch 1, fastest 1 by 0 by 21, and again I will remove this command. To remove it, I cannot negate it. I have to say.
So or you can put it in the loop inconsistent.
I will no. I will not do that actually. Wait, right? So I have removed this feature from this interface now, right? So again it will start to generate BPDU out from this interface, and again you will see that 22 have moved back into the blocking state, and it is again root, and now there is no loop, and now you see that it have, because I stopped ping, so there will not be any problem. Nothing. Then after, what will I do? Let me do one thing. Let's start continuous ping, right? And let's move back again on switch 2. And this time I will enable loop guard here at the end of switch 2, right? Because both interfaces 21 and 22 are working as a known DP. So interface range fast Ethernet 1 by 0 by 21 to 22, and then I will say spanning tree guard is what? Fine. So spanning tree interface fast Ethernet 1 by 0 by 21, and then set detail. It will show you that loop guard has been enabled on it. So spanning tree, no problem at all. Debug spanning tree events. You understand? And this time, let me move back again on switch 1 and let me say enable. No problem. Till next 20 seconds, there will not be any problem for next 20 seconds, right? And no problem related to communication as well. See, it is communicating perfectly. See, it's not it. So there is no problem. After 20 seconds now, see, this time it has blocked this 21 actually, and 22 will take some time, and you see there is no, it is dropping it, right? There is no loop, because if there is loop, then it will not show you any output here. but this time it is showing you output that it is getting dropped, because in case of direct link failure, of course, it will take at least 30 seconds. Fine. So after dropping 15 ICMP packets, it will move into the forwarding state. Let me show you. It's about to 15 now, and it will start to communicate with that. See, no problem. There is no loop now, because they switch to have put this 21 into loop inconsistent state now.
Where we will not receive BPDU, it will put that as
Exactly. Yeah, and that is why I said that you will never enable it on DP, because DP, ideally DP will never receive BPDUs, right? Till there is no problem, and if there is change in topology, then of course DP can also receive some BPDUs. Is not it?
Yeah.
So-
So we enabled it on only 21 or both?
I enabled it on both interfaces. I taught you that you will enable this feature on non-DP, and either it is RP or blocking port comes under non-DP only. So this is the uses of loop guard. Next is now BPDU guard and BPDU filter. Fine. So let me do one thing once, and one more thing. Once you will solve this problem, let's say you said again disabled here on this interface itself, then again it will start to receive this BPD over here, and 22 will move back again in blocking state, and 21 will move into the listening state, and again the convergence time will be 30 seconds. You know why? Because uplink fast is not enabled. So if uplink fast is not enabled, then again your convergence time will be 26. Sorry, yeah, of course 30 seconds. So it have moved now into the learning state, and again it will stay there for 15 seconds, and then after 15 seconds it will move into next state, which is forwarding state. See, is there any problem now? Show spanning tree. 21 has moved into normal state now. Fine. So this is the uses of loop guard. Next is like BPD guard and BPD filter, and I hope that all of you really understand this BPD guard, and I don't require to explain the uses of BPD guard and BPD filter, right?
Yeah.
I have already explained you uses of BPD filter, right? Even we have also proved it.
Just one quick question is that
Mhm.
if we enable, there is one command called spanning tree BPDU guard filter, spanning tree BPDU guard filter enable, and then there is command called spanning tree BPDU guard port fast.
Yeah, I'm coming on that. See, spanning tree port fast, default, enabled, then spanning tree port fast, BPDU, guard or filter, default. Then you can also say spanning tree port fast, BPDU, guard, default.
So what does that mean?
It means that wherever port fast will get enabled, BPD guard and BPD filter will also get enabled. And you know very well that port fast feature will get enabled only on access ports. So this is the meaning of this command, right? And you can confirm whether these features are enabled or disabled by using this command. So spanning tree is what? Something. Check it out. Right? Finally, you are having UDLD now, unidirectional link detection. And UDLD basically it is a Cisco proprietary protocol. The second thing, UDLD they developed this UDLD for fiber optical connections only, because in fiber optical you have one RX, another one is for TX, different connections, which makes one single port.
But even in TX, in normal Ethernet cable, there are four.
Yeah, but the thing is, if
two will be for TX and the other two will be for RX, right? Either 1 to 1.
but are inserting on a single switch port, right? And one more thing, if any single wire goes down, entire link will go down in case of Ethernet automatically, right? But does not happen in case of fiber optical.
Okay.
So in case if you are using fiber optical, like here there are two switches, switch 1, you understand, and this is what? Switch 2. This is for RX here, so it is gonna do here. I mean, at the end of switch 2 it will be TX. Here if it is RX, then here it will be TX, and it is a single port, right? It's like gig 0 by 0 by 1,
So
and here it is gig
equal to that one.
0 by 0 by 1 here also. Right? So if you are having this type of fiber optical cable available in between these two switches, now what if, let's say, everything goes fine, so you are having some lane users behind switch 1 and some lane users behind switch 2 as well. Let's say that this TX have become faulty now, Will it be really possible for switch 1 to transmit data to in the direction of switch 2? But still you can see that switch 2 can transmit data in the direction of switch 1. So let's assume that it was root bridge due to MAC address A and B. See, just try to understand now, right? You see, here it is Rx, this is what? Tx. Here it is Tx, sorry, it will be Rx, you understand? And here it is what? Tx. Now STP has put it into the blocking state, right? And this is what? DP, this is what? DP, this is what? RP, and this is what? In blocking state. Fine. Now the thing is, this time not this port, actually this Tx at the end of switch 2 become faulty. Are you getting my point? Even you have enabled loop guard. Let's say you have enabled loop guard, right? Are you getting my point? No?
I lost it actually.
How? This is one cable. This is one connection, another connection. There are two connections, fiber optical connection between these two switches, right? In one connection you are having RxTX, another connection also you are having RxTX. Now, switch 1 was root bridge, that is why both interfaces will become DP here. That's why I have configured here DP, and this is also what? DP. Here it have become, let's say, RP, and this is in blocking state.
Fine. Okay.
Any problem?
No.
Now, at the end of switch 2, there is a problem in TX.
Okay.
So it will keep on to receive BPD on RP here, because this is fine. There is no problem on RX. This is RX, you understand? This is RX. So on receiving via, there is no problem. So it will keep on to receive BPD, so it will remain as RP. But still the lane users cannot communicate to each other. However, you are having alternate port, but again, STP will not be able to utilize this alternate port this time.
Because the TX link is...
Exactly. So this time for STP, even after enabling loop guard, everything, root guard, it will not be possible for STP to find out this type of problem.
So within the wire, it will not be possible. I mean,
But if this TX goes down, then of course it can identify it. Hey, if this TX goes down here, then it can identify, because it will stop to receive BPDUs, right?
yeah.
So conditions are different. I got your point?
Yes.
Conditions are different. If this TX goes down, then of course STP can identify this failure.
Yeah.
But this time, because this TX has not gone down, right? This TX is having problems. So when users won't be able to communicate with each other, and you won't be able to find out the problem. For that purpose, for this type of problem, to identify, to rectify these types of problems in your network, we are having UDLD, unidirectional link detection. UDLD have mainly two types of messages: UDLD request and UDLD response. UDLD can be configured in two modes only. One is normal mode, another one is aggressive mode. In normal mode, your UDLD message interval would be 7 seconds. In aggressive mode, it will be 15 seconds. In normal mode, if it detects any unidirectional link, if UDLD detects any unidirectional, because this link have become now unidirectional. Now it is not bidirectional, right? And if your like fiber optical is already unidirectional, then of course there will not be any uses of this UDLD. The uses of UDLD will be in that case only when you are having your bidirectional port, bidirectional fiber optical port, right? So now to detect this, let's say that you are using UDLD normal mode, right? So in UDLD normal mode, if UDLD detects any unidirectional link, then it will simply generate a log message, won't perform anything else, will not perform anything else except generating a log message. But if you are using UDLD in aggressive mode, you understand what I mean to say? If you implement UDLD in aggressive mode, and then after, if UDLD detects any unidirectional link, then after, first of all, it will try to reset it by itself, and even after resetting the interface, if it is still unidirectional, then after it will put that port into error disabled state. So these are the main differences in between UDLD normal mode and the aggressive mode.
So you said 7 and 15 seconds.
Yeah.
7 seconds in normal.
Normal mode, and in aggressive mode it will be 15
So
seconds.
this, what will be this message? Like hello?
UDLD request. Yeah, hello is known as UDLD request. and of course neighbor switch has to give us have to respond with UDLD
So this is
response.
like a keep alive.
Yeah, of course, keep alive, something like keep alive, so that it will be able to detect your links. So to detect your links, UDLD will keep on to generate UDLD request messages, and of course in the response of request it will give reply,
But
right?
for 7 seconds.
Yeah, in normal mode, right?
No, but for those 7 seconds, the users will not be able to.
Of course, but you have to manage within that time, because if you configure everything like within 1 second or 2 seconds, again there will be too much extra overhead on your network, right?
Yeah.
Like if UDLD is generating UDLD request messages in every 1 second, it means there will be too much overhead on your network, right? So generally, I mean, you can also change it, it's up to you.
So do we generally enable UDLD?
Of course, in case of fiber optical you will always
But
find
in
this
case of
UDLD.
Ethernet.
No, not in case of Ethernet. In case of Ethernet, loop guard is more than enough. But if you are having this fiber optical, then do not enable loop guard. That's fine. But do not forget to enable UDLD. So to enable UDLD, again, like you understand very well that what are the commands necessary to configure UDLD. Like to enable UDLD, it's very simple. UDLD enable for normal mode. But to enable aggressive mode, UDLD aggressive, and then after enabling globally, then you have to move on under interfaces like interface range fast Ethernet 1x0x21 to 22. Then you have to say UDLD port and then aggressive to enable aggressive mode, right? Then after you can move on switch to like UDLD is what aggressive, then interface range fast Ethernet 1x0x21 to 22. Then you have to say UDLD port is what aggressive. Then you can move. You can see. You can run this command show UDLD interface fast Ethernet 1x0x21 and then what? Enter. Message interval is what? 15 seconds. Here it is showing me message interval as 7 seconds.
Any debugs to see these messages?
No. Timeout interval is what? 5 seconds. It means if it have transmitted UDLD request, it must receive the UDLD response within 5 seconds. Aggressive mode, this time its mode is what? State is what? Bidirectional. It is not unidirectional, right?
Yeah.
In this way you can
is it
enable.
possible to have some unidirectional like changing in wire or
No, in Ethernet it's not. In Ethernet it's not.
like
And on switch 2, one more thing. On switch 2, not only on switch 2, on switches you can also configure auto recovery from error disable state.
Yeah.
When you configure like error disable recovery cause, under cause you can also find this UDLD.
then recovery timer.
It means it is true that in aggressive mode, UDLD will put your interface into error disable state, right? So in this way you can configure all these things. Fine. Then after talking about all these security features of STP, let's talk about RSTP now.
No?
Yeah.
7 seconds.
Let me explain it, right? So that tomorrow we can perform the practicals of RSTP. Fine. So in RSTP, the very first difference, like here in STP, you can still see that even after enabling port fast feature, uplink fast, backbone fast, the convergence time was still 30 seconds, right? In some cases, it was too much actually for production networks. So finally, like IEEE launched RSTP, Rapid Spanning Tree Protocol, right? Rapid Spanning Tree Protocol. And the first difference in between STP and RSTP is port states. Like here in RSTP, you are having like discarding,
Blocking.
learning, and finally forwarding. Only 3 states are there.
So listening,
blocking, and disabled. First 3 states, they have combined first 3.
into discarding.
Yes,
Blocking, listening,
in discarding state.
discarding. Okay. Disabled is nothing.
Nothing.
So basically,
They have combined all those states, first 3 states, into this discarding state, right? And remember, if you talk about the RSTP, it is seriously too fast. It have fast convergence as compared to
maximum of 2
STP.
seconds, right?
Yeah,
BPDU time.
Exactly. In case of RSTP, maximum convergence time will be 2 seconds. Maximum 2 seconds.
But
Here in RSTP, the most important thing is it's not like to understand the port states and all. By looking at the port state, you can think, okay, it is learning, it is having only learning state. It means it will take 15 seconds only, right? It's not like that. It is not like that. In some cases, it will not take like 15 seconds, but in some cases, it will also take more than 15 seconds as well, like 30 seconds. So we have to understand all those situations in which it will not take 15 seconds, like it will take maximum 1 second or 2 seconds, right? Maximum 2 seconds. And we have to understand all those situations as well in which it can take more around 30 seconds as well. Remember, port fast feature is not the default feature of RSTP. In some books they have written that port fast is also like built-in feature of RSTP, but it is not something like that. I mean, it is not like that. Port fast was never part of, was never built-in feature of RSTP. BPD guard, sorry, backbone fast and uplink fast. We cannot say that these are the built-in feature, but RSTP have built-in capabilities so that we will not require to enable uplink fast here and backbone fast. Right? Now the big question is that how does it really work? To understand its working, we have to understand its, like in RSTP we are having some terminologies, you understand, like first of all proposal. There is a terminology in RSTP which is known as proposal. Second is what? Synchronization. You understand? The first thing is proposal, second is synchronization, and third one is agreement.
third one was
Agreement. If you understand the meaning by proposal, the meaning by synchronization, and the meaning by agreement, it means you understand RSTP. Because RSTP, the functionality of RSTP is completely depending only on these three things: proposal, synchronization, and agreement. So now, if you talk about the proposal, in short, in brief, I will let you know that proposal is like whenever a switch will come up, it will generate proposal messages, and in proposal messages actually it will give its own BPDU messages. During proposal, switches will exchange their BPDU messages. Fine. In synchronization, if let's say for an example, proposal is done now, right? After proposal, they will perform synchronization, and in synchronization actually, like switches will put their trunk ports into discarding state to prevent their switch network from possible breaching loops, right? And finally, switch will generate an agreement that okay, I'm RP after election of RP, right? After electing RP, then it will generate an agreement message towards its upstream, right? Towards its upstream bridge that okay, I'm RP and you must be DP. Once switch will generate agreement message out from its switch port, and a switch which receives agreement on its switch port, they will directly put those interfaces directly into forwarding state without without putting your interfaces into learning or like discarding state. I'll let you know all these things, right? Because this is quite interesting. And now the big question is that how will it be possible? Because in case of uplink fast, I told you that how switches updates their MAC table, right? But here in RSTP, we have to understand it that how switches really how switches updates their MAC table, because here we are not having uplink fast exactly, right? So there must be some method, there must be some methodology by which switches will update their MAC table immediately. Because in RSTP, if your primary root port goes down, then immediately within milliseconds your secondary root port will come up.
yeah.
So of course there must be some mechanism by which switches will update their MAC table immediately. Fine. So I'll be discussing all these things with you tomorrow. But do one thing, prepare yourself. I mean, like, you can read something about proposal message, synchronization, and of course this agreement message as well. Fine. So now we'll see you tomorrow.